Hi guys, welcome you all today for this session. So today we are going to see a small problem using k-means clustering. So our main scope of today's session is to see a problem with 9 data points, and we are going to split those 9 data points, and then we are going to put those into two clusters. We are going to form a two clusters, and we have to see like which data points fit into which cluster. Okay, so we are going to see like how those data points is going to fit into the either or one of the clusters using k-means method. So the first step is iteration 1, which is nothing but the selection of initial centroids randomly. So you have 9 data points here. Okay, you have 9 data points here, 2 to 25. You have 9 data points here, 1, 2, 3, 4, 5, 6, 7, 8, 9 data points. And then what I want to do is like I'm going to initially select a random centroid. So here I'm going to select first centroid as 4 and the second centroid as 11. I would like to tell you something here. So you can say like doesn't mean that whatever the centroid point you're going to select is going to give you the same results. Suppose if you're going to select your C1 as 2 and C2 as 25, it's not going to give you the same cluster. It actually gives you the some other different cluster. So maybe you can say like a few data points might fit into the other cluster also. So the main thing is like we doesn't know like which data points are need to be chosen randomly. That is a point here. We actually choose a random centroid, but sometimes by choosing a wrong random centroid, the cluster quality may become poor. So we can say like this might be one of the main disadvantage in k-means. So you have to carefully select an initial random centroid. Okay, and then here so you have 9 data points. So my first random initial centroid is C1, and then second random initial centroid is C2. So now I have to see which data point falls into which cluster. I have told you only two clusters I'm going to form, and then first cluster is C1 and the second cluster is C2. So I have to see whether this data point is going to fall into the C1 or C2, 4 is going to fall into C1 or C2, and likewise everything till 25 is going to fall into C1 or C2. So how will you calculate this? You calculate this by using a distance measure. Here in k-means clustering, we are going to use a Euclidean distance. So through this Euclidean distance, you are going to calculate the distance between the data point and the two centroid. So suppose if I have a data point, first data point 2, I'm going to find the distance between this data point and the two randomly selected centroid. So using a Euclidean distance. So by calculating the distance, so I have two distant measures here, D1 and D2. D1 is nothing but the distance between the data point and the first centroid, and D2 is nothing but the distance between the data point 2 and the second centroid C2. So that's what they have told. And then how we are going to calculate this? There are many distance measures. So now I'm going to choose a Euclidean distance. Usually by selecting distance measures, your answer won't vary. Mostly all of the distance measures have to give you the same results. So see here, so my 2 is my first data point. So first I would like to tell you the formula for Euclidean distance. So d of I comma j is equal to square root of xi1 minus xj 1 the whole square plus xi2 minus xj to the whole square, then up to xin minus xjn the whole square. Okay, so this is the formula of the Euclidean distance. Now I have to find the distance between the data point 2 and the centroid C1 and C2. See here, I have calculated here. So the distance between the first data point 2 and the two centroids C1 and C2. So D1 is equal to square root of 2 minus 4, which is going to be my first centroid, is equal to 2 minus 4 the whole square into square root. Sorry, into square into the square root. See here, I always consider this square and this square root is cancelled in Euclidean distance, because even if I'm going to take 2 minus 4 is 2 the whole square into square root, I'm going to get the answer 2. See here also, if it's going to be 9 square into square root, again I'm going to get the answer 9. So I always, when I'm going for Euclidean distance, I calculate like 2 minus 4, 2 minus 11, and then 4 minus 4, 4 minus 11, 10 minus 4, 10 minus 11. I directly calculate while I'm using Euclidean distance, because I feel this square and square root is always getting cancelled. So for the first data point, I've calculated 2 minus square into the square root is equal to 2. and then 2 minus 11, the whole square into square root is going to give me 9. See here, so the distance d1 is nothing but 2 minus 4 is 2, and then 2 minus 11 is going to be 9. So likewise I am calculating here. So 4 minus 4 is 0, and then 4 minus 11 is 7. So 10 minus 4 is 6, and then 10 minus 11 is going to be 1. And then 12 minus 4 is 8, and then 12 minus 11 is 1. And 3 minus 4 is 1, 3 minus 11 is 8. And then 20 minus 4 is 16, and 20 minus 11 is 9. 30 minus 4 is 26. 30 minus 11 is 19, and then 11 minus 4 is 7, 11 minus 11 is 0, and then 25 minus 4 is 21, 25 minus 11 is going to be 14. Okay, so likewise I've calculated the distance d1 and d2 for all the centroid. For your reference, I have calculated for all the data points. I've calculated for all the data points. I would like to see this for your reference. So this is for the data point 4 with both the centroid, and this is for the data point 10 with both the centroid 4 and 11. For the data point 12 for data point 12 with the centroid 4 and 11, and then the data point 3 with the centroid 4 and 11, and then data point 20 with the centroid 4 and 11, and then data point 30 with the centroid 4 and 11, and then the data point 11 with centroid 4 and 11. Likewise, I've calculated for the last data point 25 for the two centroid 4 and 11. So likewise, I have calculated for all the data points, and after calculating these data points only, I have formed this tabulation. Okay, so d1 and d2 is nothing but d1 is nothing but the distance between the data point and the first centroid point, and the d2 is nothing but the distance between the data point and the second centroid point. Okay, so now how we are going to come to a conclusion which data point is going to fall into which clusters. Okay, so we see here I'll be comparing the two distance d1 and d2. Whichever is smaller, my data point is going to fall into that cluster. See here d1 is smaller, so my data point 2 is going to fall into my first cluster. And see here d1 is smaller, so it's going to fall into the first cluster. And see here d2 is smaller, so my data point 10 is going to fall into C2. And see here d2 is smaller, so my data point 12 is going to fall into C2. And see here d1 is smaller, so it's going to fall into C1. And see here d2 is smaller, so 20 is going to fall into C2. And see here 19 is smaller, that is d2 is smaller, so it's going to fall into C2. And see here d2 is smaller, and so my data point 11 is going to fall into C2. And here again d2 is smaller, distance between the C1 and C2, where C2 is smaller, so I'm going to put my data point 25 into 2. So now likewise I form the cluster. So from here, so my 2, 4 and 3 are into cluster C1. Okay, and then the remaining all 10, 12, 20, 30, 11, 25 are all falling into the cluster C2. Now I have formed this cluster. As I have already told you, the cluster depends and also varies according to the centroids you are choosing. So you have to terminate your problem whenever you are having or you are getting the same clusters in the different iterations, even if you are choosing a different centroids. So we can see this in your forthcoming sessions. Wait. Okay, fine. So we have formed it. Okay, so the centroids, first centroid is 2, 3, 4, and the second centroid is 10, 12, 20, 30, 11 and 25. We have formed it, okay, by calculating the distance between the first centroid 4 and the second centroid 11. Okay, got it. Now, my second iteration, I have to see whether by selecting the different centroid also I am getting the same clusters. Then only I can say like, okay, this is my cluster is of good quality. So now I have to select my second iteration, I have to select my new centroid point C1 and C2 in the formed clusters. So in order to select a new centroid point, what I am doing is like I am making a mean of the data points of my cluster C1 and mean of the data points of my cluster C2. So I'm making the mean value. So 2 plus 3 plus 4 divided by 3, I have 3 data points. So divided by 3 is equal to 3. Now this 3 is going to act as a C1, and here all the data points divided by number of data points 6 is equal to 18, and now this is going to act as a centroid point C2. Okay, so now my centroid C1 is 3 and my centroid C2 is nothing but 18. So now again you are going to calculate the distance d1 and d2 in order to form your clusters. So again you are going to calculate through the Euclidean distance. So 2 minus 3 is nothing but 1, and then 2 minus 18 is going to be 16, and again 4 minus 3 is 1, and then 4 minus 18 is 14. and then again 3 minus 18 is 3 minus 3 is 0, and 3 minus 18 is 15. Likewise, you have calculated till 25. So 25 minus 3 is nothing but your 22, and 25 minus 18 is nothing but your 7. So you have calculated for all the data points D1 and D2. You have calculated for all the data points. Now we have to see which data points falls into different clusters. So again, we have to check the same procedure. You have to check which distance is smaller to this data when compared to this data point. So I can say like this one is smaller, having a smaller distance. The distance, if the distance is smaller, it means that this point is going to fall nearer to this data point. So it means like it is going to fall into this cluster. So D1 is smaller, so C1. D1 is smaller, C1. D1 is smaller, C1. And D1 is smaller, C1. And here D2 is smaller, C2. And here D2 is smaller, C2. And here again D2 is smaller, C2. And again D2 is smaller, D2 is smaller, C2, C2. And see here, now we have formed the cluster with, first cluster with 2, 4, 3 and 10. Whereas your previously formed cluster was only 2, 4 and 3. Though this 10 is actually newly added here. And now here your C2 have 12, 20, 30, 11, 25, whereas 10 is actually into C1. So there is a variation in your cluster, newly cluster formed with the old formed cluster. Okay, so now what I have to see, okay, again you have to check whether this is of good quality only. If this is not going to change in my next iteration also, the same cluster is going to be formed in my next iteration, then I will come to a conclusion that the cluster formed is of good quality, so I will terminate my problem. So I am going for the third iteration. So again you have to calculate a new centroid. So as we did in your second iteration, we are going to calculate the new centroid with the finding the mean value of the old centroid form. So 2 plus 4 plus 3 plus 10, 2 plus 4 plus 3 plus 10, by the number of points 4 is 4.75, and now here your C2 is 12 plus 20 plus 30 plus 11 plus 25 divided by the number of points 5 is equal to 19.6. So now your C1 is going to be 4.75 and my C2 is going to be 19.6. Again I am going to calculate the distance between my centroid C1 and C2 and the data points and between these two centroids. So 2 minus 4.75 is 2.75, and 2 minus 19.6 is going to be 17.6, 4 minus 4.75 is going to be 0.75, and 4 minus 19.6 is going to be 15.6. So likewise you'll calculate till 25, so you'll get D1 and D2. Again the same procedure to see which data points fits into different clusters, in which cluster C1 or C2. You check D1 and D2, whichever is closer to the data point, that is smaller, you fit that data point into that particular cluster C1 or C2. If it's D1 is smaller, it fits into C1. So if it's D1 is smaller, fits into C1. C1 is smaller, D1 is smaller, C1. And then here again C1, D1 is smaller, C1. And again D1 is smaller, C1. And here D2 is smaller, C2. And again here D2 is smaller, C2. And here this is smaller, D1 is smaller, C1. And again here D2 is smaller, C2. Okay, so now my formed cluster is 2, 4, 3, 10, 12, 11, whereas my previously formed cluster was only 2, 4, 3, 10. So now 12 and 11 is being newly added. So again there is a change in my forming of cluster. New data points are getting added into it. So what should I do? So I should go for my fourth iteration. Again the same procedure. You have to calculate the new centroid by forming the mean of the newly formed cluster. You will get C1 as 7 and C2 as 25. So again you are going to calculate the D1 and D2, and then again you have to check the difference, check the which is smaller, D1 or D2, and then whichever is smaller, your data points fits into that cluster. So C1, and again here this is smaller, C1, and again when you are coming to this, so D2 is smaller, so C2. Okay, so now my cluster formed is 2, 3, 4, 10, 12, 11 for the C1. It is same as you got the cluster in your third iteration. So now my problem is going to terminate, because in both the iteration 3 and iteration 4 I am getting the same clusters, C1 2, 3, 4, 10, 12, 11, and here also 2, 4, 3, 10, 12, 11, and C2 is nothing but 20, 30, 25, and my third iteration also 20, 30, 25. So I am getting the same clusters. So the cluster formed in the iteration 3 and 4 are the same. Since there is no changes, the cluster formed above is the final, and I conclude that this is the good quality of clusters I have formed for the problem given. For the given problem, this is the two good quality of cluster I have formed using a k-means cluster. I hope everybody would have understood. Thank you so much.